something turned on last year. Not a star. Not a supernova. Not anything we have a clean word for in ordinary language. A black hole that had been completely, perfectly silent for 100 million years? Longer than the dinosaurs existed, longer than mammals have existed, longer than the distance between what we were and what we are, turned on. And we watched it happen. The galaxy is called J1007 plus 3540. The black hole at its center is now firing twin jets of superheated plasma, relativistic matter screaming outward at close to the speed of light, across nearly 1 million light-years of space. 1 million. From a single point. Outward. In both directions. Right now, as you are reading this sentence, that jet is still moving. We don't know why it started. We know exactly how long it was silent before it did. And we know one other thing. Something that the scientists who found this data have been careful about how they say. Our black hole has been silent for the same amount of time. The galaxy J1007 plus 3540 sits roughly 3 billion light-years from Earth, in the direction of the constellation Leo. That distance matters less than you think. What matters is the structure of what's there. At the center, a supermassive black hole. Feeding, accreting, distorting space. And around it, preserved in the surrounding plasma like rings in a felled tree, evidence of what it did before. Enormous outer radio lobes. Ghost structures of ancient energy. The remains of the last time this black hole was active. Spectral aging analysis. A technique where astronomers measure how much the high-energy electrons inside old plasma have cooled, put a date on those outer lobes. The electrons in the northern lobe have been cooling without fresh injection for approximately 242 million years. The inner structures, the newer ones now screaming back to life, have a characteristic age of around 140 million years. The math writes itself. 100 million years of silence. Confirmed. Not estimated. Calculated from the physics of decaying matter, the same physics that tells a forensic pathologist when a body stopped moving. The body of J1007 plus 3540's last outburst stopped moving 100 million years ago. And now something new. The January 2026 announcement by astronomer Shobha Kumari and her team described what the Loafer radio telescope and the upgraded Giant Meter Wave radio telescope revealed. A second, younger pair of jets. Bright. Sure. Punching directly through the fossil remnants of the first outburst. They described the morphology, the shape of it, as a volcanic plume erupting through its own old ash cloud. The energy output of the nucleus during this current outburst. Approximately 6 times 10 to the power of 44 ergs per second. That number is meaningless until you scale it. The Sun outputs 3.83 times 10 to the power of 33 ergs per second. J1007 plus 3540's reawakened core is therefore radiating at roughly 160 billion times the power of the Sun. Every second. Every second since it woke up. And we are only now seeing the light of its first moments. The equivalent, if you need it in a different unit, is approximately 14 septillion 1 megaton nuclear detonations per second. Sustained. From a single point. Kumari's co-author Sabyasachi Pal stated this clearly. This galaxy shows that supermassive black holes are not one-shot monsters, but engines that can switch off and on again, reshaping their surroundings each time they awaken. Not one shot. They come back. And the question that Kumari's team could not answer, the question their data doesn't touch, is the one that should matter to you most. Scientists don't know why. Let's be precise about size because imprecision is a kindness we cannot afford here. The total radio structure of J1007 plus 3540, the full extent of everything the black hole has inflated across 2 eruption cycles, spans approximately 4.7 million light-years. The Milky Way, for comparison, is about 100,000 light-years across. So the complete structure is roughly 47 times the diameter of the galaxy you live in. But the active jet, just the new one, the one that started recently, the one still growing, reaches almost 1 million light-years. If you want to hold that number in your body rather than just your mind, try this. Take our galaxy, the Milky Way, the entire thing, for 100 billion stars, 100,000 light-years across, and shrink it to the size of a coin in your palm. At that scale, J1007 plus 3540's current jet would stretch from your hand, across the room, out the door, and continue for another 12 feet. That is one jet. One direction. There is another one going the opposite way. Same length, same speed, same energy. And both are moving outward through a galaxy that has stars in it, billions of them almost certainly, right now. As that jet advances, it is depositing shock waves into the surrounding cluster gas, re-accelerating particles, driving turbulence, stripping material from galaxies unlucky enough to be inside the blast radius. The X-ray observations confirm it. The cluster's hot atmosphere is disturbed. There are cavities aligned with the radio structures, voids punched into the gas by the force of the outburst. Can the jet reach other galaxies in the cluster? Yes, it already has. The full 4.7 million light-year extent of J1007 plus 3540 structure extends well beyond the host galaxy itself and interacts with the intracluster medium, the hot gas between galaxies, the medium in which other galaxies sit and breathe. Other galaxies are inside this. And here is the thing that should follow you to sleep tonight. Distance in this context is not a safety measure. Distance is just how long it takes for the light of what happened to reach you. J1007 plus 3540 is not singular. That is the important thing. That is the thing that changes the texture of what we're discussing. The literature on episodic AGN, active galactic nuclei that switch off and on, goes back decades. Double-double radio galaxies. Systems like 3C219 and B1834 plus 620, which show two pairs of radio lobes along the same axis. The first pair ancient, faded, cooling. The second pair young, bright, fresh. Unambiguous evidence of two distinct jet episodes separated by a dormant interval. In 2024, a Loafer survey identified 69 candidate restarted radio galaxies in a single 424 square degree patch of sky. One survey area, 69 examples, sizes ranging from 88,000 light-years to over 1.6 million light-years. 69. In one patch. The pattern is documented. Repeated. Cross-confirmed across instruments, across redshifts, across every kind of galaxy environment we've looked in. Dormant. Then active. Without warning. Always without warning. The data on every single one of these systems shows the same thing. No precursor detectable from the outside. No measurable buildup. No flicker before the flame. One day, on cosmic timescales, the outer lobes are just fading, aging, cooling plasma. Old light. And then, embedded inside it, new jets. Fresh, bright, already moving. We never caught one starting. We only ever find them after they've begun. And in every case, the mechanism that triggered the restart, the specific reason, the exact moment, the precise threshold that was crossed, is, in the words of the researchers themselves, not yet fully understood. The data exists. The explanation doesn't. Now, there is a black hole 26,000 light-years from where you're sitting. It is called Sagittarius A star. Sagittarius A asterisk sits at the exact center of the Milky Way. Its mass, 4.297 million times the mass of the Sun, confirmed by tracking the orbits of actual stars, S2, S62, others, that loop around it at thousands of kilometers per second, close enough that the math leaves no room for another explanation. It is there. It is massive. It is confirmed. Distance from Earth, approximately 26,996 light-years. Most papers round to 26,000. Right now, SGRA asterisk, as astronomers call it, is in a low luminosity state. Quiet. Accreting a small amount of surrounding gas. Occasionally producing small infrared and X-ray flares. Not a quasar. Not a jet launcher. Dormant. But the sky tells us it wasn't always. In 2010, the Fermi Space Telescope mapped two enormous lobes of gamma-ray emission extending from the galactic center. One lobe north, one south, each approximately 25,000 light-years in height. The shape, a perfect hourglass centered on Sagittarius A asterisk, rising above and below the plane of our galaxy. We call them the Fermi Bubbles. In 2020, the Rosetta X-ray telescope found something even larger underneath the gamma-ray signal, matching X-ray bubbles, even bigger, reaching 45,000 light-years above and below the galactic plane. These structures don't arise from nothing. In 2022, a modeling study by Yang et al. In Nature Astronomy concluded that both the Fermi bubbles, the Rosetta bubbles, and their associated microwave signal can all be explained by a single event, a jet outburst from Sagittarius A** that occurred approximately 2.6 million years ago and lasted roughly 100,000 years. 2.6 million years ago, our black hole briefly became a quasar. It launched bipolar jets. It inflated structures tens of thousands of light years tall. And then it stopped. We live inside the fossil evidence of that eruption. Those bubbles are above us and below us right now if you could see in gamma rays from where you're sitting. And the additional evidence, ionization signatures in the Magellanic Stream, a trail of gas extending across the southern sky, consistent with a powerful flare from the galactic center approximately 3.5 million years ago, reaching all the way to satellite galaxies. The light of something SGRA* did, still visible in the arrangement of atoms across hundreds of thousands of light years of space. It was violent. It has been silent since, for approximately 2 to 3 million years. Now, the Event Horizon Telescope in its 2024 polarimetric imaging of Sagittarius A** found strong, ordered magnetic field structures near the event horizon. Spiral fields. The kind consistent with a weak or frustrated jet, a jet that currently cannot collimate into a large-scale outflow, but that has the architecture to do so. The Max Planck Institute scientists described it this way: Sagittarius A** hosts a jet, which in contrast to M87**, is not collimated enough to blast a significant amount of matter into space, and noted that such jets can lose power, shut down, and relaunch. Lose power, shut down, relaunch. They were describing Sagittarius A*. They were describing the thing 26,000 light years from your sky. If Sagittarius A** were to enter a quasar-like phase again, and the models of AGN duty cycles confirmed that massive galaxy black holes undergo multiple active episodes over their lifetimes, the effect on Earth would depend entirely on the scale of the outburst. At 1/10 of its theoretical maximum luminosity, models suggest atmospheric stripping becomes severe within about 3,300 light years of the galactic center. Earth sits at 26,000 light years. You are likely outside the worst of it. Likely. But likely is doing enormous work in that sentence. Because here is the thing no model can tell you. No warning system exists. There is no instrument currently operating, on Earth, in orbit, anywhere in our solar system, that would detect the beginning of an SGRA* activation in time to mean anything. No alert. No countdown. No flicker of light that says, preparation is advised. We would find out the same way we found out about J1007 plus 3540's first eruption, by seeing the fossil. After. Tonight, Sagittarius A** is silent. The same way J1007 plus 3540 was silent. For 100 million years that black hole gave nothing away. The outer lobes just sat there cooling. The electrons inside them lost energy at a measurable rate, 242 million years of cooling, 140 million years for the inner structures, and then, somewhere in between, the engine that produced all of it simply stopped. No signal. No announcement. It stopped. And then it started again. We don't know why it started again. We don't know what internal threshold was crossed. What volume of cooling intracluster gas finally reached the accretion disk. What magnetic field configuration finally built past whatever limit triggers jet formation? We have theories. Several plausible ones. Galaxy mergers delivering fresh gas to the nucleus. Cooling flows in the cluster atmosphere sending material spiraling inward after a long period of jet-driven heating held it back. Cold filaments of gas from the cosmic web threading into the galactic core. All of those are consistent with J1007 plus 3540's environment. None of them tells us when. None of them could have told us from the outside watching that the restart was hours away, or a million years away, or already happening just too far for the light to have reached us yet. And that's the thing that needs to land. J1007 plus 3540 is 3 billion light years away. When we observe it, we're seeing light that left it 3 billion years ago. Whatever is happening there right now, tonight in real time, We will not find out for 3 billion years. Sagittarius A** is 26,000 light-years away. If it activated tonight, right now, this moment, the light from that activation would take 26,000 years to reach Earth. If it activated 25,999 years ago, we would find out next year. Let that sit. We are not seeing the present state of our black hole. We are seeing what it was doing 26,000 years ago. Before agriculture. Before cities. Before writing. We are watching our own galactic center with a delay so vast that the entire span of recorded human civilization, everything we have ever built, written, fought over, remembered, fits inside the margin of error. The 2026 ALMA radio map of the Milky Way's central 650 light-years, released just months ago, shows molecular clouds spiraling toward the galactic center. Cold gas threads. Filaments. The kind of material that, if it reaches the accretion disk in sufficient quantity, could change the state of Sagittarius A*. How much of it is already moving inward? We're mapping it now. What do we do with a map we received 26,000 years late? There is a particular kind of silence that comes after you understand something you cannot undo. Not the silence of nothing happening. The silence of something that has already happened, and is still traveling toward you, and will arrive on a schedule you cannot read, from a direction you cannot look away from, through a galaxy you have nowhere to leave. J1007 plus 3540 is one of 69 confirmed examples in a single patch of sky. There are more than 100 giant radio galaxies with structures exceeding 2 to 3 million light-years. There are systems with lobes reaching 7 million light-years. Every one of them was silent before it wasn't. Every one of them gave no warning. Every one of them was, for some length of time, just a galaxy with a quiet center, the same as ours. The Fermi bubbles are above you right now. The Rosetta bubbles are above you right now. 45,000 light-years of fossil evidence, centered on the thing at the center of your galaxy, reaching into the halo of the sky you look at every clear night. It has done this before. The magnetic architecture for it to do it again is already confirmed to be in place. We do not know when. We do not know what threshold is required. We do not know if the threshold has already been crossed, 26,000 years ago, in the light that hasn't reached us yet. And there is no instrument, no mission, no calculation we can perform, that would tell us before the light arrives. There is only the silence. The same silence. It kept that silence for 100 million years. Then it didn't. We are still waiting.